When we stand in front of a plane mirror, usually we see a single image for a single object in a plane mirror. But what if we have two mirrors? How many images we'll be able to see? Let's try to understand this. Images formed by two plane mirrors inclined to each other at an angle. Let's say if we have two plane mirrors, mirror M1 and mirror M2, inclined to each other at an angle theta, and here you have the object O, then let's see how many images are formed. So first of all, from the point object O, I have taken three incident light like this. This ray of light is incident normally on the surface of the mirror M1. So after reflection, it retraces its path. Another ray of light is incident like this. So after reflection, it goes along this path. Another ray of light is incident like this. So after reflection, it goes along this path. So if these three reflected rays, this one, and this one, if they are produced backward, then they appear to meet at the point I1. So I1 is the virtual image of the point object O formed by the mirror M1. So similarly, this object O is also in front of the mirror M2. So mirror M2 will also form its image. So similarly, I have taken here three incident rays of light. This ray of light is incident normally. So after reflection, it retraces its path, comes back in the same direction. Another ray of light I have taken like this. This ray of light, on being incident on the surface of the mirror M2, is reflected along this path. Another ray of light, it is incident on the mirror M2. After reflection, it follows this path. If these three reflected rays, this one, and this one, if they are produced backward, then they appear to meet at the point I2. So I2 is the image of O formed by the mirror M2. Now again, these rays of light are incident on the mirror M2. These rays of light will act like incident rays for the mirror M2. So if these rays of light are produced backward, they appear to meet at the point I1. So I1 will act like the virtual object for the mirror M2. So mirror M2 will also form its image somewhere here. So similarly, these rays of light, they are actually the reflected rays, but these rays of light will be incident on the mirror M1. So if these rays of light are produced backward, they will meet at I2. So I2 will act like the virtual object for the mirror M1. So mirror M1 will also form its image somewhere here. And the process will continue. So you can see that many number of images are formed when we have two plane mirrors inclined to each other at some angle. So in order to calculate this, we have a formula. And this formula is given by the number of images formed by the two plane mirrors inclined to each other. N is equals to 360 degree divided by theta minus 1. This theta is the angle of inclination between the two plane mirrors. Now before we calculate the number of images, although this is the general formula, we need to know certain things. First of all, we have to see whether the value of 360 by theta is odd or even. If the value of 360 degree by theta, if it is an even integer, then the number of images formed is given by n is equals to 360 by theta minus 1. So if you have 360 by theta, this quantity, if you get even, then the number of images formed, that is n, will be 360 by theta minus 1, where theta is the angle between the two plane mirrors. Suppose say if this 360 by theta, this quantity 360 by theta, if it is an odd integer, then the two cases will arise. Firstly, if the object is kept symmetrically between the two mirrors. This symmetrically means, like in this case, here you have two plane mirrors, and these two plane mirrors are inclined to each other at an angle of 40 degree. That means theta is 40 degree. This is the line of symmetry. This line of symmetry divides this two parts into identical parts, these two into identical parts. So from here to here distance is same, from here to here also distance is same. From here to here distance is same, from here to here distance is same. So this bisector of this angle can be called as the line of symmetry. Suppose object is kept here, you can say the object is kept symmetrically. If the object is kept here, you can say the object is kept symmetrically. If the object is kept here, you can say object is kept symmetrically. But if the object is kept here or here or here, then you can say the object is kept asymmetrically. Now, if the object is kept symmetrically between the two plane mirrors, then the number of images formed n will be 360 degree by theta minus 1. If the object is kept asymmetrically, then in that case the number of images formed will be n is equals to 360 degree by theta. You know theta is the angle of inclination between the two plane mirrors. Now it has been found that smaller the value of this theta, smaller the angle of inclination between the two plane mirrors, more will be the number of images formed. Greater will be the number of images formed. So I have given you two examples here, 3 examples. So first one is if theta is 0 degree. Theta 0 degree means the two mirrors are parallel to each other like this. This is mirror 1 and this is mirror 2 and the object is kept here. The two mirrors are parallel to each other. So in this case, the angle of inclination between these two parallel mirrors will be 0 degree. So in that case, if you calculate the number of images, the general formula is n is equals to 360 degree by theta minus 1, and theta in this case is 0 degree, so you write 0 degree. So something divided by 0 is infinity or undefined, so you get it like this. So the number of images formed is infinite. So infinite number of images are formed when the two mirrors are parallel to each other. This kind of parallel mirrors you can see in science cities also, where you see infinite number of images for an object. So now here we have another example. Suppose say if the angle of inclination between the two plane mirror, if it is 40 degree, then how to calculate? First of all, we'll calculate this factor 360 by theta. We'll calculate this factor 360 by theta. In this case theta is 40 degree, we are getting as 9, and you know 9 is an odd integer. So now there will be two possibilities. When the object, first one is when the object is kept symmetrically, and the second one is when the object is kept asymmetrically. Symmetrically means the object kept here, here, here like this, on the line of bisector, on the line of symmetry, on the line of bisector of this angle. So when the object is kept symmetrically, then the number of images formed, formula is 360 by theta minus 1. So here theta is 40 degree. So 360 by 40 you get 9, 9 minus 1 is 8. So in this case, when the object is, if the angle between the two plane mirror is 40 degree and if the object is kept symmetrically, then in that case 8 number of images are formed. But if the object is kept asymmetrically, let's say the object is kept here or here or here, then in that case the number of images formed according to the formula, it will be 360 by theta. So 360 by theta means 360 by 40 degree, so you get 9. Now here this is the question asked to me by one of the students. This question says that when an object is placed, number 1 asymmetrically and number 2 symmetrically between the two plane mirrors inclined at an angle of 50 degree, find the number of images formed. So first of all, here 50 degree is the angle of inclination between the two plane mirrors, that is theta. Theta is 50 degree, and we'll try to find this factor first, this quantity. This quantity is 360 by theta. So theta here is 50 degree, so you get 7.2. So this value 7.2, it has to be an integer. It cannot be in fraction, it cannot be in decimal. So you get the integral part. You write only the integral part. So integral part 7.2 I'm writing as 7. If it is 8.3, I'll write 8. So it goes on like that. So here you're getting 7. The value of this quantity 360 by theta I'm getting as 7. And you know 7 is an odd integer. Now if the value of this quantity 360 by theta is an odd integer, then you know there are two possibilities. So now you see, as 360 by theta is an odd integer, so therefore there are two possibilities. One possibility is when the object is kept symmetrically, and the other possibility is when the object is kept asymmetrically. Now first one, let's see. Number one, when the object is placed asymmetrically, then the number of images formed is given by 360 by theta. So you are getting 360 by 50 degree, that is equals to 7.2. We'll take it as number of images as 7. We take only the integral part, not in fraction or not in decimal. The second one is when the object is placed symmetrically, then the number of images formed is given by this formula, 360 by theta minus 1. So 360 theta here is 50 degree minus 1. So 360 by 50 degree is 7.2 minus 1. But this we take it as 7. Because this quantity 360 by theta, this quantity cannot be in fraction or in decimal. We have to take the integral part. We are taking integral part as 7, so 7 minus 1 is 6. So in this case, number of images formed will be 6 and 7. Number of images formed will be 6 when the object is placed symmetrically, and the number of images formed will be 7 when the object is placed asymmetrically. Now let us see if we have two plane mirrors at right angles to each other or perpendicular to each other, then how many images will be formed? So here the angle of inclination between the two plane mirrors, theta is equals to 90 degree. So mathematically, to calculate the number of images formed, first of all we have to calculate this quantity. This quantity is 360 degree by theta, and as theta in this case is 90 degree, so 360 by 90 degree will get 4. Now 4 is an even integer, so therefore if you have an even integer, then whether the object be kept symmetrically or asymmetrically, then the number of images formed n is given by this formula, 360 degree by theta minus 1. So in place of theta I'll write 90, so 360 by 90 is 4, 4 minus 1 is 3. So when the mirrors are at right angles or perpendicular to each other, or when theta, the angle of inclination between the two plane mirrors is 90 degree, then the number of images formed is 3. So let's see this in a ray diagram. So here I have taken two plane mirrors M1 and M2. These are the two plane mirrors inclined to each other at an angle of 90 degree. Theta here is 90 degree. I have taken an object O. This is in front of the mirror M1 as well as it is in front of mirror M2 also. So both the mirrors will form its image. Let's see now how the mirror images are formed. So here first of all, this O is the object. So I have taken in this diagram 3 incident rays from this point object. So one ray is incident normally on the surface of the mirror M1. So after reflection it retraces its path. Another ray of light is like this. So after reflection it moves along this path, it is reflected along this path. This is another ray of light. After reflection it goes along this path. So if these 3 reflected rays, this one and this one, if they are produced backward, then they appear to meet at the point I1. So I1 is the virtual image of the point object O formed by the mirror M1. So similarly, since object is in front of mirror M2, so M2 will also form its image. So in order to show that, again I have taken 3 incident rays. One ray is incident normally on the surface of the mirror. So after reflection it retraces its path. Another ray of light after being incident of the mirror M2 is reflected along this path. Another ray of light on being incident on the mirror M2 is reflected along this path. Now if these 3 reflected rays, this one and this one, if they are produced backward, then they appear to meet at the point I2. So where I2 is the virtual image of the point object O formed by the mirror M2. Now again you can see that this I1, which is actually the image of O formed by M1, this is in front of the mirror M2 because the rays of light are going like this, incident from it, appears to be incident from it. So this rays of light which appears to come from the point I1, image I1, these rays of light appears to come from the point I1. So I1 will act like the virtual object for the mirror M2. So these rays of light which appears to come from I1 after reflection from the mirror M2 goes along this path. One ray of light goes along this path, another ray of light goes along this path. So if these two reflected rays of light are produced backward, then they appear to meet at the point I3. So I3 is the image of I1. I1 is the virtual object for the mirror M2. So I3 is the image of I1 formed by the mirror M2. So similarly, for the mirror M1, this image I2, as it is in front of the mirror M1, so this image I2 will act like the virtual object for the mirror M1. So these rays of light, if you see these rays of light, this one and this one, they are incident on the mirror M1. So when these rays of light are produced backward, they appear to meet at I2. So therefore I2 is the virtual object for the mirror M1. So these rays of light after reflection, this ray of light which appears to come from I2, this ray of light which appears to come from I2, after being incident on the mirror M1 is reflected along this path. And similarly, this light, ray of light which appears to come from I2 after reflection from the mirror M1 goes along this path. So if this ray of light is produced backward, and again if this ray of light is produced backward, then they will meet at the point I3. So again here I4 is formed. So I4 is the image of I2 formed by the mirror M1. But I3 and I4 coincides at the same point. Now this further images cannot be formed because this I3 or I4, they are lying behind both the mirrors. So the images cannot be formed. The image of I1 was formed by M2 because I1 was in front of M2. The image of I2 was formed by mirror M1 because I2 was in front of M1. But I3 or I4, which coincide at the same point, they are lying behind the mirrors, so further images cannot be formed. So you can clearly see altogether how many images are formed: I1, I2 and I3. 3 images are formed in this case. That means when the two mirrors are placed perpendicular to each other, then in that case an object placed in front of the mirrors will have 3 images.